Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths practice questions on the trig graphs or trigonometric graphs. If you need any extra help on the trig graphs, if you go to Corbettmaths and go to the videos and worksheet section and scroll down to video numbers 338, 339 and 340, you'll see video tutorials on the cosine graph, the sine graph and the tan graph. Alternatively, you can scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, question number one. Question number one, we've been asked to sketch the graph of y equals sine x for x is bigger than or equal to 0 degrees but less than or equal to 360 degrees. So we've got our axes here. We've got our x-axis and our y-axis. Our x-axis goes from 0 all the way to 360 and a bit further. And our y-axis is going down to -1 and up to 1 and actually a little bit further above and below. So we want to draw the graph of y equals sine x. Y equals sine x. Now this is a calculator question, so you could do the sine of 0, so sine of 0 degrees, and you'll get that's equal to 0. The sine of 90, you'll find that's equal to 1. The sine of 180 is equal to 0. The sine of 270 degrees is equal to -1. And the sine of 360 is equal to 0. So you'll get those values. And it is a calculator question, so you can type those in. But it can actually be useful to know those off by heart, actually knowing the shape of the sine graph, that it starts at 0 and comes up and down and so on. Now it says to sketch it, so we need to do our curve. So our curve is going to look something like this. And that's it, that's my sketch. Now I tried to do this on the computer and it's actually not that easy to do the curve on the computer, so that's the best I can do. If you've got pencil, feel free to try and do the curve a little bit better whenever you're doing it on paper. And that's it, that's our sketch of y equals sine x. Okay, let's look at question number 2. So question number 2 asks us to draw a sketch of the graph of y equals cos x for x is bigger than or equal to 0 degrees but less than or equal to 360 degrees. So in our last question we were sketching the sine graph, now we're sketching the cos graph. So again, it's a calculator question, so that's quite nice. You can just do on your calculator the cos of 0 degrees, the cos of 90 degrees, the cos of 180 degrees and so on. And you'll find those values to be 1 for the cos of 0 degrees is equal to 1, the cos of 90 degrees is equal to 0, the cos of 180 degrees is equal to -1, the cos of 270 degrees is equal to 0, and the cos of 360 degrees is equal to 1. So that means our curve will look something like this. And that's it, that's the sketch of y equals cos x. That's the cosine graph. So we started at 1, we went down to 0, down to -1, up to 0, and up to 1. And again, I've tried to draw the curve on the computer, which is quite tricky. So whenever you're doing it on paper, just obviously try and do the best you can. Okay, let's look at our next question, question number 3. Okay, so question number 3, we've been asked to sketch the graph of the tan graph, so the tangent graph. So we've got our axes here, and we've got our horizontal axis and our vertical axis. Now this time you'll notice that the horizontal axis does go from 0 to 360 and a bit further, because we've been asked to sketch it for x is bigger than or equal to 0 degrees but less than or equal to 360 degrees. But in terms of the vertical axis, the numbers aren't actually labelled apart from 0, because they're actually going to go up to infinity and off down to infinity and so on. Now again, it's a calculator question, so if you've got your calculator, feel free to work out these values. Okay, so let's start off with the tan of 0 degrees. The tan of 0 is equal to 0, so that's going to be there. Now the next one, the tan of 90 degrees. Whenever we work out the tan of 90 degrees on our calculator, if you do the tan of 90 degrees, you'll find that's equal to a math error. So it's going to be a math error. So what I'm actually going to do is let's actually just go a little bit to the left of 90 and let's do the tan of 89 degrees. And let's see what we get for the tan of 89 degrees, just to see what happens to this curve. So the tan of 89 degrees is equal to 57.2899 and so on. 57. So what happens is this graph shoots up like so. Okay, and then at 90 degrees, because there's a math error, it's what we call an asymptote. So it's an asymptote here. The curve won't touch that line. So what's going to happen is the tan of 0 is equal to 0, and as you work out the tan of values, they're going to keep getting bigger and bigger, and they're going to shoot up like so. So they're going to go off to infinity. And then we've got where x is equal to 90 degrees is an asymptote. And then let's do the tan of 91 degrees on our calculator, the tan of 91 degrees. And you'll find that's equal to minus 57.289 and so on. So it's going to be down here somewhere. And then if we did the tan of 180 degrees, the tan of 180 degrees is equal to 0. So what's going to happen to the curve is it's going to start down here and it's going to come up and then it's going to reach 0, like so. And then the tan of 270 degrees is a math error as well. If you do the tan of 270 degrees, you get the math error. So it's going to be an asymptote as well. It's undefined. So it's going to be an asymptote, like so. It's meant to be straight. Okay. And so if we do the tan of 269 degrees, what do we get? Just going a little bit to the left of 270. And that's equal again to 57.289 and so on. So what happens is this curve actually shoots up again like so. So just run that middle bit again. And as you can see, the curve goes up and up and up and up and up. And then whenever x is equal to 270 degrees, we have another asymptote. And then the curve's going to then come down here, and then it's going to come up, and at tan of 360 degrees is 0. The tan of 360 degrees is equal to 0. And then it starts going up again. So that's our sketch of the tan graph, y equals tan x, where we have the graph starting at 0. It then goes up. We've got an asymptote at 90 degrees. It then comes up, reaches 0 at 180 degrees, and then goes up again. Another asymptote, and then comes up, reaches 0 at 360 degrees, and so on. Okay, let's look at our next question, question number 4. Okay, so let's have a look at our next question. So our next question says, shown as part of the curve of y equals sine x degrees. So we've got the sine x graph, and here we've got the points A there and B there. And we've been asked to write down the coordinates of the point A and the coordinates of the point B. So it's quite important to know the shape of the graph. So here, that's 0 degrees, and sine of 0 is equal to 0. Here, we know that it reaches the maximum point here at 90 degrees. So whenever x is equal to 90 degrees, we get 1. So that's equal to 1. So that means at that point will be 90 degrees, 1. So 91. Okay, here the height of the graph is 0, so that will be 180 degrees. Okay, here the next point B, that's going to be 270 degrees, and the height of it's going to be -1, because the sine x graph goes between 1 and -1, so that will have to have a height of 1, and that will have to have a height of -1, and it reaches that first height of 1 at 90 degrees, and it reaches that height of -1 at 270 degrees. So that's it. So that's 270 degrees and -1. So the coordinates to the point A are 91, and the coordinates to the point B are 270 degrees, -1. Okay, let's have a look at our next question, question number 5. So question number 5 is a bit similar to question number 4, but this time we're dealing with the cosine graph rather than the sine graph. So we're dealing with the cos graph rather than the sine graph. Okay, so here we've been asked to write down the coordinates of the point A and the coordinates of the point B. So in terms of the cosine graph or the cos graph, we know it goes between 1 and -1. We know that it has a height of 1 at 0 degrees, so it has a height of 0 at 90 degrees. So the coordinates to this point will be 90, 0. It reaches a height of -1 at 180 degrees, so 180 degrees, -1, and then that would be 270 degrees, 0, and so on. So the coordinates of the point A would be 90, 0, so 90, 0, and the coordinates of the point B are 180 degrees, -1, so 180 degrees, -1, and that's it. Okay, let's look at our next question, question number 6. So question number 6, we're told, here's the graph of y equals cos x for x is bigger than or equal to 0 degrees, but less than or equal to 360 degrees. So we've got our axes here, and they go between 1 and -1. And part A says, use your graph to solve cos x is equal to 0.5 between x is bigger than or equal to 0 degrees, but less than or equal to 360 degrees. So we want to find whenever this graph has a height of 0.5. Because then we can find what the value of x is, in other words, the number of degrees. You might actually know this already if you've looked at a topic called exact trig values. You might know the cos of something is equal to 0.5, but let's have a look at our graph and see if that can help us find it. So 0.5, so here's 0.5, and as you can see here, the graph has a height of 0.5 here. And if we go down, we can actually read off and see that's 60 degrees. So x is 60 degrees. So that means that the cos of 60 degrees is equal to 0.5. So that's one of our answers, because we're asked to solve the cos of what is equal to 0.5. X would be equal to 60 degrees, or there's another height. If we actually carry on our curve, there's actually another angle with a height of 0.5. If we get to here, that's got a height of 0.5 as well, and that's equal to 300 degrees. So x is equal to 60 degrees, or x is equal to 300 degrees. So there's two possible solutions, 60 degrees and 300 degrees. So between 0 and 360 degrees is two angles that will have a cos of 0.5, and they're 60 degrees and 300 degrees. Okay, let's have a look at part B. Part B says, use your graph to solve cos x is equal to minus 0.5 for x is bigger than or equal to 0 degrees, but less than or equal to 360 degrees. So this time, rather than being 0.5, we're looking for minus 0.5. So I'm just going to change color of ink here. I'm going to go to blue, and then if we go back up to the graph, we want to find the angles that whenever you do the cos of that angle, you get an answer of minus 0.5, and therefore angles between 0 and 360 degrees. So let's look at our graph, and let's find where the height is minus 0.5. So if we go along, there's one angle, which is equal to 120 degrees. So whenever x is equal to 120 degrees, if you do the cos of 120 degrees, you'll get minus 0.5. Or if we go along, we can find another angle, and that's equal to 240 degrees. So that means that between 0 and 360 degrees, there's two angles that if you work out the cos of them, or the cosine of them, you get an answer of minus 0.5. And they're 120 degrees and 240 degrees. So let's write that down. So we've been asked to solve this equation, and our answer would be x is equal to 120 degrees, or x is equal to 240 degrees. So there are two possible solutions. Okay, let's look at our next part, part C. So part C, we've been asked to use the graph to solve cos x is equal to minus 0.75 between 0 and 360 degrees. Okay, let's change colour of ink again, and this time we're going to green. So if we go up, we're looking for an answer of minus 0.75. So minus 0.75 will be here, minus 0.75. That will be there, but halfway between minus 0.5 and minus 1. So we want to find the angles, and whenever we work out the cos of those angles, we'll get minus 0.75. So let's go across. So if we go across, so we get to here, which is the third little box there, and then if we go up, it's the third little box there between 120 and 150. So let's find out what value that would be, or what angle that would be. So there's 30 going between 120 and 150, and there's 1, 2, 3, 4, 5 little boxes. And if we do 30 divided by 5, that's equal to 6. So if we go up in sixes, we've got 126, 132, 138. So that's 138 degrees. So our answer would be approximately 138 degrees. Okay, and then if we get to the other one, here we can see it's two little boxes beyond 210 degrees. So if we then go up, we'll find that's equal to, so that's where we are. And that would be 210, so then 216, 222. And that's it. So that means the two angles would be 138 degrees and 222 degrees, approximately. If you actually work them out, and you actually work out the cos of 138 degrees, you actually get that's equal to minus 0.743 and so on. But using the graph, that's our approximate answers. X is approximately equal to 138 degrees, or X is approximately equal to 222 degrees using the graph. And that's it. Okay, let's look at our next question. Okay, so question number 7, part A, says sketch the graph of y equals cos x for x is bigger than or equal to 0 degrees but less than or equal to 360 degrees. So we want to sketch the cos graph. And now we should know that already. So go through the point 0, 1, 90, 0, 180 degrees, negative 1, 270 degrees, 0, and 360 degrees, 1, and so on. And let's draw a curve the best we can. And that's it, that's my sketch of the graph y equals cos x between 0 and 360 degrees. And then we're told one solution of the equation cos x equals 0.766 is whenever x is equal to 40 degrees. So let's have a look here. If we have 40 degrees, so 40 degrees, well 45 is in the middle, so 40 degrees is roughly there. And if we go up and across, then that height must be 0.766. Obviously this is my sketch, so it might not be perfect. And then we're told to find the other solution of that equation between 0 and 360 degrees. Okay, so we're told whenever x is equal to 40 degrees, that's going to be there. Then if we go up to here and across, we're told that is 0.766. So the cos of 40 degrees is 0.766. But I've been asked to find the other solution. But actually, if you go across on your curve, you'll find there's another point with the same height. So if we go across like so, we can find here that this other point with the same height. And then if we go down, we can figure out what it would be. So if this is 40 degrees here, so 40 degrees from the beginning, this point here will be 40 degrees before the end. So for instance here, if we've gone from 0 to 40 degrees, here, this point, because the graph is symmetrical, if this is 360 degrees, this would have to be 320 degrees. So 320 degrees. So the cos of 40 degrees is also the same as the cos of 320 degrees. And the graph is symmetrical. The cos of 1 degree will be the same as the cos of 359 degrees, and so on. So that would be 320 degrees. Okay, and then part C. Part C says use your sketch to work out the value of cos of 200 degrees. Okay, so we've been asked to use our sketch to work out the value of the cos of 200 degrees. Now we're using our sketch, so it's not going to be perfect here. So we want to find the cos of 200 degrees. So here, the next line, it's in the middle of 180 and 270. So that's an increase of 90 degrees. So 45 degrees would be in the middle. So that'd be 225 degrees when you have 45 onto 180. So 200 degrees will be, well, roughly there, just slightly to the left of the middle. And then if we go down and we go across, we get to here. And I'm going to say, well, if this is 0.5 and that's minus 1, I'm thinking, is that perhaps around about minus 0.95, something like that? Again, it's an estimate. We're using our curve to do it, so it's not going to be exact. We haven't even got the little boxes to help us. So I'm going to go for minus 0.95. So minus 0.95. And if you've written down minus 0.9, something like that, that would be fine using your curve, okay, to find that value. And that's it. So I've gone for minus 0.95. And actually, let's just work this out to see what it was. The cos of 200 degrees is equal to minus 0.939 and so on. Okay, so roughly minus 0.94 to 2 decimal places. Okay, let's look at our next question. Okay, let's have a look at our next question, question number 8. So question number 8, we've been given three graphs, graph 1, graph 2 and graph 3, for values of x between 270 degrees and 360 degrees. So here's our three graphs. You can see that little section of the graphs being drawn for each of them. And then part A says which one's the sine graph, part B says which one's the cos graph, and part C says which one's the tan graph. Okay, so let's have a look at them. This one here is going to be the tan graph. I know it's a tan graph because it goes past -1, because whenever you've got the sine graph or the cos graph, they go between values of -1 and 1. Whenever you work out the sine of an angle or the cos of the angle, the answer is always between -1 and 1. Because this graph goes beyond the -1, it goes down -2 and so on, that's going to be the tan graph. So that's going to be y equals tan x. And actually, if we sketch the rest of the graph, what would it look like? It would actually go up like so. We'd have an asymptote there at 90 degrees. It would come up. It would cross at 180 degrees and go up again. Another asymptote there at 270 and so on. So that's the tan graph. So these graphs, graph 2 and graph 3, one of them is going to be the sine graph and one's going to be the cos graph. Let's carry on the graph. So remember, they go between -1 and 1, and they follow a bit of a pattern. So here if you've got 1, then 0, then this one will be -1, and then 0, and then 1. This one, if that's -1, it'll then be 0, 1, and then 0 again. So this graph is the sine graph. I know that one straight away because it starts at 0. So that's going to be y equals sine x. And this one, y equals cos x. And let's just have a look at, so here it starts at 1. So the cos of 0 is equal to 1. And it goes down to 0, down to -1, and back up to 0. So that's the cos graph. So part A says write down which graph is y equals sine x. That's going to be graph 3. Part B says which one's cos graph, that's graph 2, and then the tan graph is graph 1. So our answers are 3, 2, 1, and that's it. Okay, let's look at our next question. So question number 9. Question number 9, we've been given a graph here. It's a sine graph, and it's between 0 and 360 degrees. And we've been told that the one solution of sine x is equal to -0.5 was whenever x is equal to 210 degrees. And we've been asked to find another solution to sine x is equal to -0.5. So let's look at our graph. And so here, we want to find when the height is -0.5. So -0.5 will be there, -0.5. And we've been told that one solution, if we go across, the one solution here, this point here, is whenever x is equal to 210 degrees. And we want to find the angle, the other angle, whenever we work out the sine of it, we also get that's equal to -0.5. So if we go on along to the next height, where it has a height of -0.5, which is here, and go up, we'll find it's this point here. So let's consider this part here between 180 degrees and 360 degrees. And this part here will be symmetrical, so there'll be a line of symmetry for this part of the graph whenever x is equal to 270 degrees. So for instance, the sine of 271 would be the same as the sine of 269. The sine of 181 would be the same as the sine of 359, and so on. So here, this angle here of 210 degrees, it's 30 degrees after 180 degrees. So that means that this angle will be 30 degrees before 360 degrees. So that'll be 330 degrees. So that's it. So the sine of 330 degrees would also be equal to -0.5. And that's just focusing on this part of the graph and knowing there's a line of symmetry here for this part here of the graph. Okay, so the other angle will be 330 degrees. Okay, next, part B. Part B, we've been asked to find the solutions of sine x equals 0.5 between 0 and 360 degrees. If you know your exact trig values, you know straight away that's equal to 30 degrees. I know that the sine of 30 degrees is equal to 0.5, and it's quite useful to know those exact trig values. So let's go up here. So 0.5. So 0.5 is here, and so that's 0.5. And if we go across, we can find one angle here, and if we go down, and I know that one's equal to 30 degrees already. And then if you go across, then you can find the other one here, and then if you go down, and again this part here of the graph is symmetrical. So for instance, the sine of 1 degree would be the same as the sine of 179 degrees. The sine of 10 degrees would be the same as the sine of 170 degrees. The sine of 30 degrees would be equal to the sine of 150 degrees, because if this is 30 degrees from the beginning, this would be 30 degrees before the end of that little section of the graph. So it's going to be 150 degrees. So that means our solutions will be 30 degrees and 150 degrees. There are two solutions, and it's quite useful to know your exact trig value. So if you go to Corbettmaths and look up exact trig values, or if you've got the revision cards, the exact trig value revision card will be quite useful for you, and that's knowing that the sine of 30 degrees is equal to 0.5. Okay, let's look at our next question. So question number 10 says the angle x is an acute angle. So that means that it's between 0 and 90 degrees. And we've been asked to circle the correct statement that the tan of x is less than 0, the tan of x is equal to 0, and the tan of x is greater than 0. So is it negative, 0, or positive? So let's consider the tan graph. So there's our vertical axis and our horizontal axis, a little sketch here. And with the tan graph, we know that it's got an asymptote at 90 degrees. So we know that whenever it's a right angle, the x is 90 degrees, that's undefined. So there's an asymptote there at 90 degrees. So that's 90 degrees. Now the tan of 0 is equal to 0. And then as you work out the values of tan of 1, tan of 2, and so on, it increases and goes up like so. So as you can see here, whenever you work out the tan of an acute angle between 0 degrees and 90 degrees, you're going to get a positive answer. The tan of 45 degrees is equal to 1, for example. So the tan of this acute angle will always be positive. It's above the x-axis. So that means that tan x will be greater than 0. So that's our answer there. And that's it. Okay, let's look at our next question, question number 11. So question number 11, we've been told that the angle x is such that this angle x that we're looking at is bigger than 270 degrees, but less than 360 degrees. So perhaps it could be 300 degrees. And we've been asked to circle the correct statement. So the tan of the angle is negative, and the cos of the angle is negative. The tan of the angle is negative, but the cos of the angle is positive. The tan of the angle is positive, but the cos of the angle is negative. And the tan of the angle is positive, and the cos of the angle is positive. So what I'm going to do to help me in this question is actually sketch both of the graphs. So let's start off with the tan graph. We know there's asymptotes at 90 degrees and 270 degrees. So that's 90 degrees and 270 degrees. And we know the graph starts at 0 and comes up like so. It then comes up, reaches 0 at 180 degrees, and then goes up again. And then the bit we're interested in between 270 degrees and 360 degrees, well, the tan of 360 degrees is 0, and then it comes up like so. So between 270 degrees and 360 degrees, this part of the graph, the tan of the angle will be negative. It's below the x-axis. So it's quite useful to know that, the shape of the graph, and to know that the curve will be below the axis between 270 and 360 degrees. So the tan is going to be negative. So that means it's either this option here or this option here. So it can't be that one or that one. So it's either this option or this option, because here we've got the tan is negative for both of those. So now let's consider the cos graph and consider it between 270 and 360 degrees and find out if the curve is above or below the x-axis. So the cos graph starts up here at 1, it then comes down to 0, it then goes down to negative 1, it then comes up to 0, and then goes up to 1. And that's 360 degrees. So that's 0 degrees, 90 degrees, 180 degrees there, 180 degrees, there would be 270, and here's 360 degrees. And we're interested between 270 and 360 degrees, so this section here. And as you can see here, it's above the x-axis. The cos of this angle will be positive. So that means that the cos is positive. So it means the tan is negative and the cos is positive. So that means this is our answer here, that the tan is negative and the cos is positive. And that's it. Okay, and let's look at our last question, question number 12. Okay, let's have a look at our next question, question number 12. So question number 12, we've been asked to sketch the graph of y equals minus cos x for values of x that are bigger than 0 but less than 360 degrees. There's a few different ways we can approach this. One approach is actually just use our calculator, and we could type into our calculator minus the cos of 0 degrees minus the cos of 90 degrees, and so on. And you could do that for all of the angles. So if you do minus the cos of, so minus cos 0 degrees, you get that's equal to minus 1. If you do minus the cos of 90 degrees, that's equal to 0. Minus cos 180 degrees is equal to 1. 270 degrees would be 0, and 360 degrees would be minus 1. So you get that shape there. So that's one approach you could do. Another approach you could use is actually to consider, well, minus cos x means minus 1 times cos x. So it means you're multiplying the values of cos x by negative 1. And that will change the signs, because if you multiply something by negative 1, you change its sign. So the points that were positive will then become negative. The points that were negative would then become positive, and the points that were 0 would still be 0. So that's why you get those points. Or another approach is to actually know the transformations of graphs, and actually using that previous approach that we just talked about, to actually know that whenever you put a minus sign in front of a function, it flips over the graph, it changes the signs. So what happens is the graph flips over, and that's what's happened here. If we actually join up these points, And excuse my sketch, not necessarily the best one. But as you can see here, this is the cos graph, but it's been flipped over. The cos graph normally starts at 1, goes through 90 degrees 0, 180 degrees -1, 270 degrees 0, and 360 degrees 1. But here, whenever we change the sign, we multiply by -1, what happens is the points that were above the x-axis go below the x-axis, and the points that were below go above, and the points that were on the x-axis stay where they are. So it's a reflection in the x-axis. And that's it. But that's it. But it was a calculator question, so you could just type into your calculator and get those points. And that's it. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on trigonometric graphs, or the trig graphs. I really hope you found this video useful, and if you have found it useful, please like and please subscribe to the YouTube channel. And it's really important to know what those graphs look like, the graph of y equals sine x, y equals cos x, and y equals tan x. And if you need any extra help on those, if you go to Corbettmaths and go to the videos and worksheet section and watch your videos 338, 339, and 340, there's dedicated video tutorials there on each one of the trig graphs. Alternatively, you could scan this QR code. And another topic which might be quite useful for you as well is exact trig values. And at the end of this video, if you're watching on YouTube, I'll put up two little icons. One's to subscribe to Corbettmaths, so please do that. And the other one is the link to the video on exact trig values. And if you watch that, that'll be useful for you as well. But I really hope you found this video useful, and thanks so much for watching. Cheers, bye.